matrices, we're actually going to see them this week actually doing something functional, actually transforming shapes. So the first thing I want to introduce you to is what's called the unit square. Okay, that's supposed to be a square. So it's going from O to A to B to C. So please try and remember that order, and it's just 1 unit in length. So the coordinate of A is 1, 0, the coordinate of B is 1, 1, and the coordinate of C is 0, 1. So that's really when we refer to the unit square, that is what we're talking about. So I was saying to some of those who arrived earlier, my plan is I'm just going to turn the pages on this quite quickly, because obviously all of it's new to you. It's not like I can just model 1 or 2 of them in depth. So what I think I'll do, I'll turn the pages quite quickly, and then I will stop the recording. You guys can then ask whatever questions you want. I think I will upload these work solutions quite quickly, so that you, as you're working through, you can look at my work solutions, which are a bit more color coded perhaps than the Corbett Maths official solutions. And then if you want some more practice, I've popped a lot of questions onto Dr. Frost's Maths. Okay, I took all the questions they had on matrices, matrix transformations. Please don't feel obliged to do them all. Okay, it's just, I just thought if they were there, you could just dot around as and when you see fit. So there's a number of questions to kick off where they're just asking you to map a coordinate. Okay, so find where the matrix 5, -1, -2, 3 maps the point -3, 1. So all you have to do here is change that coordinate into the single column matrix, the -3, 1, and then you just multiply it just like you were doing last week. Okay, so we've taken the matrix, the point that it's mapping, we've turned into a matrix, we've multiplied the 2 matrices together, and we're being asked where it maps to. So it's going from a coordinate to a coordinate. So once you've got that -17/6 by way of your matrix work, please just turn it into a coordinate. So I think that was the first few questions in the worksheet. So all the same principles. Okay, it's just sometimes we've got some unknown letters, but that's basically what's going on. Questions 1 to 5. Okay. Right, now question 6. Okay, this is the first time we're really coming across that unit square. So we're told that OABC is transformed by the matrix 1, 0, 0, -1. And where does it go to? It goes to O. When we plot it, they want us to call it O, A dash, B dash, C dash, because O never moves. So O and O dash are the same thing. So A dash is where the coordinate A moves to, B dash where B moves to, and so on. So all you are actually doing here is you just work your way around the various coordinates of O, A, B, and C and multiply them by that transforming matrix. So if you look at the top on the right, I've just started off with the origin just so you can see it in completeness. And obviously, if you're multiplying any 2 by 2 vector by 0, 0, you're going to get 0, 0 again. So that's not surprising that O dash is O. Okay, then the second purple one down, that's me working out where A maps to, and then where B maps to, and then where C maps to. So I've just literally taken the matrix that was in the question, and I'll just go and highlight it now. We'll see what sort of lag we've got. So that I'm just circling, oh, there is, yes, that I've just circled in purple. So that was the original origin, and it moves to the same. Then I've taken point A and gone and done the matrix to see that it maps to A dash, and so on. Now, what you will notice is when you get familiar with these, is that the matrix that you're given to transform by, that 2 by 2 matrix, that 1, 0, 0, -1, that first column by definition is where A dash maps to. So do you see how that's got, I've just highlighted in green pen on the left, the 1 and the 0. So just by looking at it, you can basically say, well, that's where A dash goes to. So I didn't really need to do, I'll just go and do it in green. I didn't really need to do that workings on the right hand side that I've just done in green, because I can just look at the matrix and see that that maps to 1, 0. And similarly, I didn't really need to do the fourth column, working out where C maps to C dash, because that is, sorry, I'm just going to have to shut the door. Elsie's being a bit disruptive. Elsie, by the way, is my dog, not my wife. So then that bottom one on the right, do you see that workings I did there to work out C going to C dash? I could have seen that the answer was 0, -1 just by looking at that second column. So what I would suggest you do is just practice the skill of just taking a coordinate and seeing where it maps to, but then try and pick up that shortcut of noticing that the first column in that transforming 2 by 2 matrix is where A dash goes to, and the second one is where C dash to. It just slightly speeds things up. So anyway, once I've gone and worked out those 4 coordinates, I've popped those onto the graph in purple, and you can just see that just by looking at the shape, I can just see that the red one has moved to the purple one. That is just a reflection in the x-axis. So lots of questions like that. Do you see how on this one I've just tried to do it quicker? I haven't gone through all these workings on the right hand side like I did on the previous one, like I did on this one. Oh, I'm just trying to go back. It's lagging now. Okay, so I've avoided doing all those workings on the right hand side with this new one. Okay, because I know the origin stays as the origin. I know that A dash is the 0, 1, and I know the C dash is the -1, 0. So just with that knowledge, I can really quickly go and write down my transformed unit square, the purple square, and then clearly that's just a reflection in the y-axis. So as I said, I would suggest you just practice the skill so that you know how to do it. You know how to do it anyway, but then very handy if you can remember the shortcut that orange column is where A dash goes to, and the green column is where C dash goes to. So we have a number of questions practicing that skill. So here we go with question 8. Again, I've done this the quick way. Okay, I've seen that A dash goes to -2, 0, and I've seen that C dash goes to 0, -2. I've gone and the origin remains unchanged, so I can very quickly draw in my revised square, and then I can just see what it is. So that is one. Do you remember those negative enlargements where you go the opposite direction and it's twice the size? So that is an enlargement by scale factor -2, center of the center enlargement being the origin. So and then again, similar questions. Okay, I've been asked to go and explain that mapping. I can see that again, I'm getting used to the idea that the matrix that I've actually used, work out matrix M. Okay, well, I can do that very quickly by just taking the coordinates of where A dash has ended up. Sorry, I meant to choose the green. So A dash has ended up at 0, -1. There's my first column on the left, and where C dash ended up, that's ended up at -1, 0. So hence that second column. So again, I repeat, it's nice that you can mechanically work these things out, but there is this shortcut of appreciating A dash is your first column and C dash is your second column. So once I've uploaded these answers, I suggest you spend a little bit of time just seeing how I've mathematically worked out that the vector of the matrix is what it is, but then do try and pick up that shortcut of just focusing on the A dash and the C dash. Yes, number 10, I just want you to get used to the word invariant. The point 4A is invariant when transformed by the matrix. That just means it doesn't move. Okay, so there it is before the transformation, and it ends up still being 4A, and then I've just done the algebra to work out what A is. So invariant means it doesn't move. Nothing new on these questions. Again, so yeah, so the bit that I've circled in the purple, and when we get to question 14, it's just a slight lag. We're going to get to question 14 in a few seconds. You'll see that all the workings in the middle is me just sort of confirming how it all works. But I want us just to focus on the shortcut. There is a bit of a lag now, so I'm just going to wait for 14 to kick in. There we go. So everything that I've done inside that purple area, that is just me working it out algebraically what the matrix becomes. Okay, I've just gone and set it up and said let this matrix be A, B, C, D, and I've just worked it all out just by mechanically. So do please follow that through. But it's so much quicker once you know that A dash is the first column and C dash is the second column. So what have I done here? Work out the matrix that transforms the unit square by a 90 degrees anti-clockwise rotation. So I've just started off by drawing my unit square in the top left and rotating it 90 degrees about the origin. So I've just sort of rotated it. I can then see where A dash, B dash and C dash is. And then I've used my shortcut of knowing the transforming matrix. The first column is the coordinate of A dash, which is 0, 1. And the second column of the final answer is where C dash moves to, which is -1, 0. So all that work I've done in the middle, proving the matrix, I've done the short, you can just do the shortcut way. So as I said, be comfortable with both ways, but make sure you can do the shortcut way. So more of the same for 15 and 16 and 17. So you see all the time I'm saying you don't really need this. 18. Yeah, and again, you see, describe fully the single transformation represented by that. So I knew that first column was going to be where A dash ends up at the coordinate 5, 0. And the second column, 0, 5, is where C dash ends up. So I did a quick sketch of that. So I'm going from that small red square to that big large green square. I can see what the single transformation is. It's an enlargement, scale factor 5, center of enlargement 0, 0. So I've used my shortcut knowledge of A dash, C dash to draw a sketch to help me gather my thoughts. And just by looking at the sketch, I can see what the enlargement is. So 19, 20 was just a bit more algebra mapping, as was 21. Nothing new there. All there. All there. I mean, they're a bit, I mean, you'll need to have a look at them, but it's just what I've been going over. And then, yes, 25. Yeah, let's have a really quick look at 25. OK, so this was the most complicated of the lot. So if you can cope with this, you're there. So the unit square, so that's our red one, is transformed by Q, R and S. And we're told that R is a rotation and Q and S are reflections. And we're basically told it's equivalent to transform the unit square by the identity matrix. Do you remember that was that 1, 0, 0, 1? That basically means we've got to end up back where we started. OK, so I needed, so would you see what we go Q, then R, then S. So we've got to go reflection, rotation, reflection, and end up where we started. Reflection, rotation, reflection, and end up where we started. So I just started off over on the right by doing a quick sketch, and just by trialing and error, a reflection, a rotation, and a reflection that got me back where I begun. So first of all, I did reflection in the y-axis. Okay, if I reflect, excuse me, this I've done down, this is the diagram down on the left, So I've taken my unit square, reflecting it in the y-axis, it gives me, I'm now at the blue one. Rotating by 180 degrees, I'm now at the black one. And then by reflecting in the x-axis, I'm back where I started at the red one. So just all that stuff in the middle is me just just by doing a diagram, finding a combination of reflection, rotation, reflection that takes me back to where I started. Because that's what they asked me to do. QRS, reflection, rotation, reflection. There probably are other ways of doing that. So this is the bit that slightly confused me at first. All right, we've now got to each time going back and starting with the unit matrix down at the bottom for our final answer, go and say what matrix does those three things I've said on the right. So our answer for Q is what matrix represents a reflection in the y-axis. Okay, so remember what we're saying. So that's the diagram. So in the y-axis, so that's the one over on the left that I'm just doing in light blue. So where does A dash C dash end up to go to do Q reflecting in the y-axis? So A dash ends up at -1, 0, and C dash ends up at 0, 1. Hence that answer for Q. Now, for R, this is where I went wrong to start with. Don't go and do it from B, from the blue one as your starting point. You need to just go and put down as your answer for R, how would you represent a rotation by 180 degrees about the origin by way from the point of view of it happening to the unit matrix, so the red one. So that's the diagram I've done at the top. Okay. When I go and rotate by 180 degrees, when I rotate the red square, where do I end up? Where is my A dash C dash? And you can see that my A dash is at -1, 0, and my C dash is at 0, -1. Hence my middle answer for R. The third one I had to do was then to pop into matrix form S, which is a reflection in the x-axis. So that's the bit that I'm just going to highlight in purple. How do I represent a reflection in the x-axis? Starting off with the unit matrix, okay, A dash becomes is still at A, isn't it? So that's the 1, 0. And C dash becomes 0, -1. That's when I reflect in the x-axis, hence my answer for S. So, a bit waffly, sorry about that. Let me go and stop the recording.